Lesson 75, Writing the equation of a line. First, let's review linear equations. A linear equation is an equation that will form a line when we graph it. We can tell whether an equation is a linear equation because it'll have these things. One or two variables, usually x and or y, and no variables raised to a power other than 1. So here's some examples. X equals 3. It only has one variable, but it's raised to the first power. 2x equals y plus 1 has two variables there, also raised to the first power, or x minus y equals 4. Here are some nonlinear equations. 2x plus y minus z equals 5, not linear because it has three variables. X squared plus y equals 2, not linear because the x is raised to a power other than 1. Or y to the negative 1 equals x, again, not linear because of that negative 1 power on the y. Horizontal and vertical lines in our linear equations will be special cases. A horizontal line will always have the same value for y. So its equation can be written, the general form is y equals k, where k is any real number. So here we see this horizontal line, and the y value is always 3. So its equation is y equals 3. A vertical line, on the other hand, always has the same value for x, so we can write its equation as x equals k, where k is any real number. So this vertical line here always has an x value of negative 2, and so its equation is x equals negative 2. When we are writing the equations for lines, we always want to put them into slope-intercept format. Slope-intercept format can be used for any line that is not vertical. Vertical lines are the only ones you can't do with this. And it's y equals mx plus b, where m is our slope. That is how many units the line rises for every unit increase in x. So if our slope is 2, if m equals 2, that means that for each unit we move to the right, each unit we increase in x, it will go up 2, will increase y by 2. Similarly, m equals negative 1/2 means that the line goes down half a unit for each unit you move to the right. B in this slope-intercept format is our y-intercept. It's the value of y where the line crosses the y-axis. So if b equals 4, the line will cross the y-axis at the point 0, 4. And if b is negative 1, the line will cross the y-axis at the point 0, negative 1. Notice that for both of those points, the first coordinate is 0 because the y-axis is located at 0 on the x-axis. So at the point where a line crosses the y-axis, the x value has to be 0. Let's take a look at this in practice. So if we're given an equation in slope-intercept format, here's how we'll graph it. First, we plot the y-intercept. It'll always be at the point 0, b, because the y-axis goes along where 0 is on the x-axis, and then b will tell us where on the y-axis that point will be. Then we'll use the slope to find us a second point. What we'll do is we'll start at that y-intercept, we'll move one unit to the right, and then up or down according to the slope. Once we have those 2 points, then we can draw a line between them. Let's see some examples. First off, y equals negative 2x plus 1. So b is 1, and m is negative 2. Since b is 1, we know that our y-intercept will be at the point 0, 1, right there. Now, to find the second point, we use our slope. So we move over one to the right, and we move up or down the number of units that m is. In this case, negative 2. So we move right 1, and then we move down 2, and that'll give us our second point there. Then we can draw a line between them. Let's look at another example. X minus 2y equals 4. Now be careful because this one is not currently in slope-intercept format. Notice for slope-intercept format, we have y by itself on the left. This one does not have y by itself. So the first thing we need to do is rearrange it so that we have y by itself on the left. First, we'll subtract x from both sides, get negative 2y equals negative x plus 4, and then we'll divide each side by negative 2 to get y by itself. So negative 2y divided by 2 on the left, and negative x plus 4 divided by negative 2 on the right, gives us y equals 1/2 x minus 2. Notice that those negatives on the x cancel out, and the negative 2 cancel out, and then 4 divided by negative 2 gives us negative 2. Now, our slope is 1/2, and b, our y-intercept, is negative 2. First, we'll plot our y-intercept. We know it'll be at the point 0, negative 2. There it is. And then for the slope, we move 1 unit over to the right, and then because m is 1/2, we'll move half a unit up for that second point. Then we can draw a line between them. Now sometimes we saw just now that we had a slope of 1/2, and that was easy enough to do because moving up or down 1/2 of a unit and drawing that accurately is not too difficult. But if it's something else that's not a whole number, this is a useful way to find a second point that will be easy for you to locate accurately. First, we'll make sure that the slope is a fraction with a positive denominator, and then we'll move right the number of units of the denominator and move up or down the number of units of the numerator. Let's see how this works. So for example, in this equation, y equals -3/5 x plus 2. b is 2, and m, our slope, is -3/5. Now, finding that y-intercept is easy because it'll be at the point 0, 2 because b is 2. But for our slope, m equals -3/5, going down 3/5 of a unit after we move right one is going to be a little difficult to do accurately. So what we can do instead is we move right the number of units in the denominator. So we move 5 units over, 1, 2, 3, 4, 5. And then we move up or down the number of units of the denominator. Here, since it's -3, we move down 3, 1, 2, 3. And that'll give us the second point there to draw our line through. Now, to go in the other direction, to go from a line that we see on a graph to finding the equation of it, we'll need to find the slope of the line. And we'll also need to find the y-intercept. But the slope is a bit more complicated, so we'll talk about that first. First, we need to understand what slope is. The technical definition of slope, m, is delta y over delta x. And the delta there, that means change. It's a Greek letter, delta. It's not a triangle. And the change in y divided by the change in x. So the change in y is the second value of y minus the first value of y, so the difference between those two values of y, the change in y, over the change in x, the second value of x minus the first value of x. Notice I use those subscripts there to keep them straight. We can use any 2 points on a line to find the slope. This means that we can find 2 convenient points to use to find the slope. If there's a point on the line which is partway between whole units on the graph, we can choose to use a different point to find the slope. So we'll find the differences between the two x values, between the two y values, and divide it by the difference between the two x values. Now make sure that when you get your answer that you have it either positive or negative correctly. Sometimes if you mix around these two or these two, you'll end up with either a positive slope where it should be negative or negative where it should be positive. You can tell just by looking at the line whether it's positive or negative. A positive line will slope up to the right, and a negative line will slope down to the right. Let's try it in practice. So remember the formula for slope, change in y over the change in x. So we'll subtract the first value of y from the second value of y, and then again on the bottom, x2 minus x1. So we can choose any 2 points as long as they have integer x and y values. Now they don't strictly have to, but it's going to be easiest for us if they do. And then we'll plug those into the slope formula and divide out. All right, so for this line, I'm going to use 0, 4, the y-intercept, and then I'm also going to use this guy here, 3, 5, because both of these will be nice and easy to work with. Right here. We put them in here. So y2 minus y1. The second point, the y is 5, and the first one, it's 4. So 5 minus 4 on top, and on the bottom, we subtract the x values. Again, we subtract the second x value, 3, from the first. It's the second x value minus the first x value. 3 minus 0, we get 3. 1/3 is our slope here. And we can check this. We see that 1/3 is a positive slope, and in fact, it is sloping up to the right. Once we have the slope for this line, then we can write the equation of it in slope-intercept format. Y equals mx plus b. We'll find the y-intercept where it crosses the y-axis. We already used that point, 0, 4. So b is 4, that y value there. Then we find the slope, which we just found. We said it was 1/3. And then we can use those to write the equation in slope-intercept format. Y equals 1/3 x plus 4.